There we go. Thank you. Okay, hello everyone. My name is Milen Chechev, and I'm going to introduce you to forecasting, and as I name it, modern forecasting, at the next 45-50 minutes. What's the agenda for today? I'm going to tell you a little bit more about myself, why I'm speaking actually to you, why I'm speaking about forecasting, plus my background with machine learning as well. And after that, I'm going to start consecutively with introducing a little bit to the problem, showing how we are going to solve it as a machine learning problem. After that, what's the current state of the art? You're going to see a little bit about transformers, about GPT-4o, and which was released 2 days ago. And yeah, we're going to see some real-time real-world examples and pre-trained models. So starting quickly with myself and my background, I'm working at the AI SWAT machine learning area for the last 15 years. As I have started at the area of recommender systems. After that, I was a little bit at online advertising, robotics, reinforcement learning, and for the last 3 years, actually, I'm at FOCT as at that position head of data science, where we are mainly focused on forecasting. So this is why the topic is today's for forecasting. As when I'm speaking about forecasting, I'm going to speak with all the machine learning experience which I have for now. Quickly about my education, I had a PhD at Massachusetts. I was a little bit for some time also abroad at our university at Finland, where I saw how actually the university need to teach machine learning, and we have lots of machine learning courses. And I came up again at Bulgaria, and I'm teaching at Sofia University. I'm teaching recommender systems actively, deep learning now, deterministic algorithms, and also other subjects as well. So, starting from the beginning, what's forecasting? I hope that everyone knows here, but still, to be fine, we have a signal, which signal we have a history about. And we need, from some point at time, to say for the future how this signal is going to continue. Right? The problem could become very, very complex, but more or less this is the definition. We have a signal which is on y-axis, it's traveling through time. So we have on x-axis we have time, and for some period of time, which we are naming the forecasting horizon, we need to say how this signal is going to look like. It's like, predicting the future, right? Forecasting. So this, for the last 100 years, it was analyzed quite a lot, and quite a lot of statistical methods was done. As things which was identified is that we could extract from this signal, for example, this is the signal, we could extract things like trend, seasonality, and something what's left. As this what's left is important, and we are going to see actually how we are mentioning it. But trend and seasonality, for example, is very well defined at the different problems, and it's cited and close. In the introduction description for the talk, I have written that this is a problem for 100 years, and actually it is. We have out regression method, which was invented actually at 1927, so 97 years ago. And starting from there are quite a lot of different statistical methods which was introduced. As the main idea is that the humanity always wants to know the future, right? In place of this, it's inventing more and more methods which are predicting as good as possible the future. As actually some of these methods are relatively strong from the last 10 years as well. As the main idea here is that having a signal, you want somehow to be able to model it, and with modeling it, you are using out regression, exponential smoothing, and you're going with ARIMA actually to introduce auto-regression and moving coverage, and after that adding seasonality, adding additional data, and so on, with extending these models. But actually, what I'm going to speak more about is how we could solve these problems with another domain, which is machine learning. As at the machine learning, we have different areas, right? We have supervised, unsupervised, reinforcement learning, and part of the supervised learning it's named regression problems, regression models, which actually eventually it looks that they could be used for time series forecasts, right? As if we look actually how the model is, the problem is defined, it looks different. And this that it looks different, we are going to actually make it look the same. It's the point. But how it looks different, the regression problem at machine learning is defined like this. We have multiple points, which these points are actually your history from which you are learning, right? And these points is something what happened in the past. This is, let's say, some signal from a sensor or something like this. And you want actually to make a model, which here is just this straight line, which model for the future is you are able to use it and to predict future dots where they are going to be, right? So it looks a lot more different, mainly because actually, first of all, what's similar, both are using historical data, right? So both the statistical methods and the machine learning methods, which I was showing, both are using historical data, both are giving numbering value as an output based on some the history, which is also numbering values, right? But the difference is that actually the forecasting is working on time series data, so actually the points are coming one after another, so sequence is important, and the time is just one direction, right? So everything what happened in the past is never going to be repeated with the same day and time, right? It could be repeated as a behavior. We could see the same values, but the time itself is not going to be repeated, right? It's going to be at new time at the future, which actually is different from the regression model where you're expecting more or less the same or similar thing to happen with the similar feature in order to forecast value. And the time series is in explicit token, right? Compared with the training data for the regression, which doesn't need to be at explicit token. So if we think of it as continuation, right? So we could say that regression, more or less, is if we have multiple points. If we have multiple points, its regression looks like it's interpolation. So between the data, somehow fitting it, and the forecasting looks like extrapolation. So the data is coming to here, and after that, how it continues, right? This is how it looks for now. And if we leave it like this, we actually cannot use regression for it. So we are going to see at the next slides how we are going to change this. So just to give you a little bit flavor how difficult it could be the forecasting problem, just think stock market, right? If it could be solved perfectly, it's never going to be a challenge, right? So, but it's challenge for multiple years, and it's never, you never know it's going to go down. So first probably we need some motivation. Why to use machine learning instead of statistical methods? Because we saw that the statistical methods are actually developed for 100 years, right? So why actually change something which is working, right? So the main thing is that events and complex situations are actually difficult to be handled from statistical methods. There are, of course, variations, extensions of the original methods because people are working on them. But still, what we believe is that machine learning could find more complex patterns, and with this actually to be able to solve the problem better on more complex domains. And yeah, having this motivation in mind, let's see now first how we could integrate eventually events into statistical methods. It's not an easy. Again, there are some work, but one of the options, for example, to use to extend the classical statistical method with some expert knowledge, rules, lots of details, and based on this actually to make it work. Right? The statistical methods with events as well, with variety of events. But this is actually going to do expert systems versus machine learning. Right? So the expert systems are working quite well if there is a limited. They're working a lot better than machine learning. There is limited amount of data, right? But when we have big data, when we have lots of data, actually the expectation is that it's going to be too complex to maintain expert systems. So you definitely want to go into machine learning area. Actually, this is something what I was able to do at the company which I'm working for. So when I have entered the company 3 years ago, the forecasting system was using statistical methods and lots of expert rules and stuff. And with this, it was working well, right? But it was developed for years, right? For 10 years. And actually, within the first 6 months with machine learning, we have made better system compared with the old one. So this is just how better machine learning systems are, with expert systems. Okay, so moving to machine learning solution, right? So what we need in order to be able to solve the problem test regression problem? First, we have this problem. First, we need to see how to model the problem as a regression problem. After that, how to solve it and how to evaluate it, right? As for the modeling, we know that we have this time series, right? And somehow we need to use it for machine learning, because the machine learning usually you have the features, and you have all the samples described with their features, and you have target feature. And we have only one feature for every point, right? Which is date. Is this enough? No. So we need to do something in order to be able to do it, to work with it. And actually, what we could do is actually to use this sequence, to know that it's sequence. And for every point, we could extract multiple features which are from the for every point we could extract multiple features which are let's say from behind, right? So for every point we could say, oh, this is the value here, but also we know what's the value 7 days ago, 30 days ago, 365 days ago. So we could extract what features. Another thing which we could do is actually to look into a window. So it's sometimes working, sometimes not. To look into a window, and actually for a window to extract different features, we could extract trends. We could extract what's the mean from the window, the maximum, the minimum, and so as of course there are also easy way to extract this, even though sometimes it's heavy, like libraries like tsfresh. Yes, it's sometimes yes, right? So you use library like this and to extract multiple features, tens of features for every point, and with this actually to prepare the problem for solving it with machine learning integration as a regression problem. And getting this that we already have now lots of features for every point, and actually the point value is the target value which we want to learn from for the past and to forecast it for the future. With this, we need somehow to design the experiment. So I'm going to speak here about cross-validation. There is why I'm going to speak about it. mainly to actually show you the difference between the time series data and the regression data. Otherwise, yeah, this cross validation for the regression problem, general regression problem, probably is not so needed for you to know. But the main idea of machine learning is if you have a limited amount of data, this is mainly when cross validation is used, you could actually split this data for multiple chunks. Here we have it on 5 different pods, and you could leave one out for testing and use the other for training. And if you're doing this 5 times, so you train 5 models, you could have actually various on which you are testing for every chunk. So actually you could test on every value without to make a data link. Just you need to train 5 different models. Right, so this is the main idea of the cross validation. So it's you're testing on mock data, and you're also training on mock data, because if the extreme patient is leave one out, so you're leaving also only one sample for testing and training on everything else. So actually you're using the as most as the biggest possible data, right? So this is for the regression problem. Do you see any problem if you're using this for time series?
Yes.
Yeah.
The stems are not taken into account. Not taken into account sequence.
Yeah. So yeah. Okay. All this is like this. We have first transformed the time series now, and we have it now with features. And so eventually we could have this strategy. Just it's making data link if you're doing this. Why? Because as I said, the time is never going backwards; it's going only forward, right? And based on this, some stuff which is happening at the future eventually could never happen in the past, right? So the past is not knowing about it. So if you're, for example, having this model here, so testing on the past, but you already saw the future, it could be very easy task, right? So let's say we have a time series signal which is very low at the first period, and after that is going very high, and it's very high at the second, third, fourth, the fifth period, right? Training on this data for the second period, your model is going to be really good, right? Because it already saw 3 different periods where the signal is high. But actually, it's impossible, right? Because on this moment here, if it was a real forecasting, it cannot know about the future, so it cannot perform it. So it's going to mislead. Right. So for a regression, again, when the data is just without time sequence, right? You could do this and actually use this. But when the time is actually and the data is the most important, we cannot do because it's data. So what actually to do that? What we could do is actually 2 different procedures. Sliding window versus expanding window. As again, we are going to see how to apply this as some kind of cross validation procedure. But this time, let's say that we are now here at this moment. What we could do is again to test on different periods of the past, as we could also overlap them. We could test for different periods of the past, and actually to see how the model performs if we train on different data. Here, the main idea is actually to evaluate how the model is performing on variety of data. This is one of the expressions. The other one is expanding window. It's actually the main difference for me is from where the data start for training, right? So the gray is the data for training. The yellow is the data for testing. The main thing what we are achieving with this strategy, because we could use, let's say, just phase 5, right? It's testing here, but training on the most data, right? So this model probably is going to be the best, right? But what's the problem with it? Anyone? So why we need also these things here, not just this one? how we are going to get more from these tests. I'm going to tell you. So let's say that we are now trying to forecast what are going to be the sales of the restaurants for May, or it's for the next weeks, for the next month, right? We're going to say this. We want to say this, and we're training a model which is evaluated, which is trained of let's say 5 years of data, and it's evaluated here on the last 2 months, right? So it's April, and the beginning of May. Actually, this is important to see how the model performs on the latest data, because it's possible that, let's say, the restaurant become popular, you have now more sales compared with the previous year and so on. So this is important testing. But actually, you don't know how it's going to perform on the next months. You don't know, and it's possible that it's completely different for the next month. Let's say the schools are stopped working, right? So actually, based on this, the restaurant is now selling half of the stuff which it was selling for. And this is something what we were seeing in the past, right? And eventually the model could learn it, you just don't know because you haven't tested it, right? So with this procedure, actually with testing on different intervals, we have actually more confidence in what's happening, right? So for example, let's say that you're making this procedure for the last year, right? And on every 2 months or every 3 months, you're evaluating the model. You could see how the model, the same model, if it didn't know about the data last year at the same time, how was it going to perform, and also how it's going to perform with having more and more data, and how it's going to perform on the latest data. And based on this, you have more evidence to actually increase your confidence in how it's going to perform the next time period. And yeah, compare these two, why there are two. I prefer this one, to be honest. There's a big difference. This one, its trend is always on the same amount of data. So let's say if your model parameters depends a lot on the how big is the data, it's going to be the same, right? This one, you're increasing the amount of data. But what we have actually different between here and here is that you're removing some part of the data, right? So actually, you see how the model is performing, let's say, last year at the same time which you want to forecast here. And it performed like this because of this data here, right? But the next model is actually removing it, right? So you're not sure. And also, at the end, you probably want to train on all the data, to have even the latest data in order to have the best model, right? But you just don't know how it's going to perform the model if you increase the amount of data. So probably you are going to need another parameters to the model, right? So this is the preferred approach.
And also, if you want to go to the left approaches, if you want your model to forget.
Yeah. Actually, for time series, sometimes it's better to forget for some stuff. For example, COVID. Probably you want to forget some years like this, but that's different. Okay, just quickly on regression, simultaneous regression, root mean square, mean absolute error. At forecasting, what I have noticed is that a lot more is used also percentage error, so like mean absolute percentage error or weighted absolute percentage error, as you want also see what's your error in percent, because this could affect your business. Okay, that's the beginning, right? So now, what's the current state of the art? And how easy we could define what's the current state of the art? We are all seeing around the generative AI models and stuff like this. Are there the current state of the art? This is something else. We need actually active research and comparison here. And for some time, actually, probably the easiest way to see what's the state of the art is actually to follow the latest competitions, right? So this M5 competition was, for example, the competition which I was following as results when I have started 2 years ago. As the main idea here is that you have a competition which is with real data, big data, which is for sales from Walmart, and actually probably the models which are working well there are going to work for similar big problems, right? As what was the state of the art of the same competition? The main things which was used there and which have presented good results was gradient boosted algorithms, right? XGBoost by GBM, this was all the probably the first 3, 4, 5 winners was doing this. Of course, not just this, right? So ensembles of them and lots of additional techniques to get even closer to the test results, right? But the backbone XGBoost by GBM, so gradient boost algorithms. So moving forward, so this M5, actually these M competitions are progressing for the last 20 something years. Right? So M5 was the 5th competition, M6 is the 6th one, the 7th one is coming probably later this year. Right? M6 competition is actually forecasting of the stock market, right? So they're taking direct data from Yahoo Finance. Actually, there are some column notebooks and stuff like this which you could use and actually just to take the data from Yahoo and to continue from there. And at this competition, the main thing is that you want to forecast the stock market, and actually it was running for 1 year. So you was forecasting always the future, right? So because if you're forecasting the past, it's very easy to cheat, right? You have already what happened in the past. So actually it was running for 1 year, and for this 1 year, every quarter there was winners, right? Which was the winners which was forecasting the best the stocks. It's very interesting. 100,000 submissions, 300,000 money price. Actually, the money price for the time which the guy has spent there is just not. What's the state of the art of this competition? What do you think? It's just say February 2023. Stop. Yeah.
Visual interference.
Which one? Transformers. Yeah. This was something what I was also looking around to see. Is it? No, it's not. So gradient boosted algorithms. And what probability forecasting, because actually probability forecasting is what's needed a lot there, because you need to have some confidence when you're buying stocks, right? So it's not enough to have a forecast. It's going to be $100 more. It's how confident you are. But the state wasn't changed again. This is February 2023 to transformers. Quickly, why? So we have gradient boosted algorithms. It's very simple technique which is used boosting, which is actually of course gradient boosting, extreme gradient boosting, so different optimizations to make it faster and stuff, or make it on GPU. But the main idea here is that you train models consecutively, more or less. It's all the time when you're training model, you're seeing where the problems, and you're updating the next models to try to solve these problems, right? So very simple technique, and this is very simple, and also it could be trained on GPU as well for XGBoost by GBM. It could also perform still quite a lot on big data. This is why it continues to be stated there for the M6 competition as well. For the ML models, the challenges, of course, when you're solving it is feature generation. So you need somehow to, if you're using these methods, they're not with attention and stuff like this. You need to actually give them what's important, right? So actually, you're doing quite a lot of feature generation. You need also to babysit the model, right? To not overfit, with you doing this hyperconvergent tuning. You need some explainability when you see the result. Actually, explainability for all the machine learning is important, but it's still a challenge, right? Continuing with forecasting challenges, actually, not just for M6 competition, but just in general. When you're doing forecasting, it could be short, medium, and long-term forecast. For example, what we are doing is we are doing forecasts which are going to 50-minute granularity. And these 50 minutes is going to vary to what items are going to be sold on 50 minutes interval, and it's going for days, for weeks, and we have even models which are forecasting for a year in advance, right? So of course, with expanding, so the accuracy is going down, right? Just because, for example, the business, when you have a business, it needs to also be able to forecast what's going to be for the next year because it's making budgets, right? So this forecasting for the next years is also important, not just what's going to happen in the next 50 minutes, right? What's going to happen in the next 50 minutes could be the easiest task, right? Let's say, but you need, for example, what's going to be in a week from now because you want to make some labor scheduling, right? And you want to know what's going to be for the next year for budgeting purposes. There are multiple things, so multi-serial forecasting. So not forecasting one thing, but many things. It's a challenge, and for example, with aproaches, it's difficult to do. With let's say deep learning, you could get multiple outputs. With aproaches, there is multi-output regressor stuff, which is slower, bigger. So there are challenges there. Hierarchical forecasting. When you are forecasting on multiple levels, right? And these multiple levels are not independent to each other, right? So you want somehow the things to sum up, right? You cannot say, I'm going to have sales of, let's say, 5,000 for a day, but if I'm splitting after that to food, drinks, desserts and stuff, and I sum all the stuff, it's 6,000, right? It's just no sense, right? So you want to have hierarchical forecast, and you want to be accurate on every level because different levels are used for different things, and you want to sum up, yeah.
The hierarchical forecasting, have you made such kind of experience for, let's say, categorization and then see the cannibalization?
Yeah, of course, we have worked on this. Just for hierarchical forecasting, M5 competition, for example, is really good because you could see there it's Walmart data, and you have different promotions and stuff, and you have 1,000 items at the store, and when the price of one thing is smaller, it's actually cannibalizing from other things. Right? So it's not, the sales are not increasing. Right, the sales are staying, let's say, the same or probably a little bit increased, but some items are changing quite a lot. So this is an organization which is a problem when you're going on the hierarchy and trying to be accurate on every level.
For this hierarchical forecasting, what is the best technology to use?
Aproaches.
Again,
I mean, that's backbone, right? Of course, it's not so simple. You'll be using it with multiple models, combining them and stuff. But this was the backbone which was built again on M5 competition.
Something else also Facebook have made, it's hierarchical, it's abbreviation. They have a model for if you have a categorization of the products. So for in different products based on their category, because sometimes they're overlapping. So there is also something.
Yeah.
For the retail.
It's not profit.
You have, like, imagine you have 1,000 products and there are in 10 categories.
Mm-hmm.
So you make
exactly hierarchical.
Yeah. So they have such kind of.
Of course, not just Facebook. I mean,
I mean, there are indeed they have. I need to check.
It's very popular problem, right? So as the forecasting in general, right? It's important when you're going into details, when you're going for to solve the problems to optimize your business. It turns out that it's one value is not enough, right? You need to multiple values which are affecting each other and so on. Another thing is with promotions, A/B test. So it's promotions, for example. If you're making promotion, you want somehow to understand how it's going to affect your sales. But sometimes it's even not possible to see from the to know what's going to happen with the historical data. So on historical data, you're making your hypothesis, you're saying, oh, this is acting as I'm expecting. After that, you progress with the data test, actually see what's happening. And yeah,
I was just about to say that if you want to forecast for promotions, then maybe it's best even to include the seasonality and longer period of time.
It's not just for promoting, for everything is important to include seasonality and longer period. So the best is if you're from our experiments, if you have 5 or more years, it's the best. If you have less, let's say if you have let's say you have COVID, right, which was 4 years ago, right? You could say, okay, I'm going to exclude COVID because it's very bad data. I'm going to use just the last 3 years. Our experiments are showing that it's better to handle COVID and to extend and to use 5, 6, 7 years of data instead of just cutting the data, right? Of course, if you're not handling it, if you're just using the sheet data, that's going to ruin your model. But if you're handling it, it's better.
What would be the minimum time period? Because in my experience, we use between 6 and 12 months due to lack of data.
Yeah, the
I
minimum.
think it's short.
Yeah, the minimum is really depend on your feature set, and probably it could go as low as, I don't know, a week of data, right? I mean, the model would work. It's not going to be good, right?
Yeah.
But it could start. And this is something for, let's say, for reinforcement learning, you could have new location starting, right? So you already know a lot about multiple locations, but you have new locations starting, and you don't know what is it, and you don't know, for example, how to manage it, right? You could use some strategy to explore and exploit in order to progress with it. And just because I'm working at that domain, I'm going to give you a little bit examples of target domain demand forecasting. So we are making forecast day sales per sales item type and per item as well. Forecasting those sales per interval, right? So 30, 60, even 50 minutes. All this depends on how many people are working. So actually, we need forecasting of labor demand as well. So how many people need to work? But actually, from this, how many people are actually working depends how many sales they're doing. It's very interesting. And we need short-term, medium, and long-term forecasting of sales. And all this is with events. So we have weather could affect sales, right? So it's very rainy outside. Nobody wants to go to a restaurant. Everyone's using delivery, for example. So delivery is shopping. You have lots of events, internal, external events. It could be events on TV, events which are happening around the location. There could be different events, so sport, culture. There could be promotions which are happening within the restaurant. Promotions which are happening at the other restaurants. Strikes, global events, and lots of other different actions and events which could affect the performance. Yes.
When you have this forecasting on daily sales per item, are you making a model per item, or you are trying to generalize?
Good question. So both ways are possible. So there are 2 approaches, right? So going bottom up and going top down. So if you're going top down, you are actually going on daily sales, and after trying how to distribute to split it, right? Because we want to make the numbers. Right? The other one is you are forecasting on the lower level, and after that aggregating to go to the top level. So with hierarchical forecasting, usually it's somewhere at the middle, right? So you're probably doing both of them and somehow combining to much numbers as can.
How do you forecast the nationality of clients? The expected nationality of clients?
Nationality.
Yes, nationality of clients per given day.
Yeah, this could be influenced somehow, but actually we are not, because it's currently we are using here just what I'm showing is sales on location, but actually this with nationality, what we're saying is could be different kind of events. Let's say Ramadan is starting, so actually we have lots of people which are celebrating this. So actually, the sales during the day are going to be very low, right? Eventually. But this, we are not trying to make this with the nationality. We are trying to make it with actually, seeing how it match with different holidays, right? And this is, for example, religious holidays, which could affect.
So about the events,
Yeah.
do you apply some function on the entering data, or it is are they pre-processed before building the model, or it is a post-processing?
It's if you want to learn from data, you need to pre-process. You need to know the events at the past, right? So I will give you just an example, right? So you have let's say a location which is affected from football matches, right? It's just next to the national stadium here, right? And you have the data for the last 7 years, and you don't know the football matches which was happening for the last 7 years, but you know them now, right? It's not very useful, right? Because you don't know how actually these football matches are affecting, right? You could start collecting data, and you could start to build, for example, a model which is going backwards and annotating for you that this was most probably an event as the this, right? You could do something like this, but you need to have this information and the training data in order to use it for the future data, right? So did I answer the question?
Yes, but here is another thing you mentioned for reinforcement, but
Yeah.
is it possible to do it with self-learning or forecasting, or it's quite fantastic for now?
So actually, I'm going to go a little bit different question. What you're asking is actually that you're starting with some business, right? It could be that even you don't have a history, right? You're starting, you don't know what was the best, how actually to start, right? So this is the situation which reinforcement learning could help, because it could actually explore for you different options and with this to make the things better. For example, I will give you an example. It could be also for past when you have history as well. Let's say you have a history, right, of a restaurant, and this restaurant is always having very low sales at Saturday, very low sales. And the management on this restaurant was very poor. So always on Saturday there was one waiter, right? And because of this, it cannot actually make sales, right? But you see based on other locations that it's possible for Saturday to generate more money. You see that this location is similar as the other one. It have a garden, it have many sales, let's say Friday and stuff like this. So it's possible also to make eventually more sales at Saturday. You cannot see this at history because there was never a second waiter at Saturday. But if you have a reinforcement learning model, it could explore to say, oh, I want one more waiter, right? And eventually with this to see more sales. And I'm saying eventually because if people, for example, was always complaining at Saturday, right, and not having enough weight, probably because of this, they're not going to come immediately, right? So for the reinforcement learning for exploration, you have also this problem: how much time you need to spend for exploration before actually to say, oh, yeah, this is the result, and to continue with expectation. But yeah, this is a different topic, which is out of the presentation for now. So yeah, I need to continue now with the application. Yeah.
Just one last question regarding the two approaches that you mentioned, bottom up and top down.
Yeah.
Maybe it's worth sharing an example when one is good and when the other one, like in this case.
Yeah, it's not very, it's not so simple. Actually, yeah, what I would just try to show the problems, right? So if you're going from the top to the bottom, right? It's more stable, quite more stable, because the top, the overall sales, you know them, right? You have there are more sales, so it's easier, it's bigger number, it's less noise, let's say, at the top cells. So it's easier. But when you're going on the bottom cells, let's say you have an items which are sold very infrequently, right? You have one cell on every 5 days, but sometimes it's 5, sometimes it's 10. So it's actually quite tricky. And if you're saying every day there's going to be one cell, you're going to be wrong at 4 days, and just to be right at 1 day, right? So actually this having more cells on the lower level could be bad, right? But it depends actually what you want to optimize, right? So if you want actually, and what's worse for you, if for example it's worse for you to not have this predicted, compared with predicting it but not really happening, it could be that you want actually to go on the lower level. And yeah, it's not just this, right? The topic is even more complex. But the main thing is that you have quite a lot of noise on the bottom level, right? So to be honest, yeah, most of the times when we was doing it, it's always from the top to the bottom, right? But yeah, there are research, there are also results which are showing that from the bottom to the top, it's also possible, right? Just you need to handle all this noise and to be able to somehow match the numbers on the higher levels, right? After that. Okay, so all this what I show you is actually what we are building as a top AI platform for hospitality. So we are forecasting sales, items, who needs to work, and so on at one platform. And this is actually quite popular. I'm making here a comparison with another forecasting problem, which is weather forecast. And we have DeepMind. This is how I have tried to include this question, because it's interesting. It's actually something what's important to know, and it's on the forecasting domain. So November 2013, it's just 6 months ago, actually DeepMind have released a weather forecast, which from their claim and their papers, it's the best in what's available right now at the world. And actually, they are showing that hundreds, thousands of actually meteorological people are now using these models in order to improve the forecast. And this the forecasting of weather is actually quite complex, right? It's because you have lots of different things which are interacting with each other, right? And they're doing this with using graph neural net. Again, here there is no transform graph neural net, which they're using for this. November 2023. Actually, DeepMind are using transformers for quite a lot of things, but for here they have to choose graph neural net. And with this, we are going to a question: could you use transformers for forecasting? Correct. November 2023, right? Still no transformer. And actually, there's quite a lot of research. I can put here just some good papers, which after that you could see the presentation. But starting from the last 3 years, right? There's quite a lot of research for exactly applying transformers for forecasting. It's starting with Informer. After that, they're going to temporal fusion transformer. They're showing that there are problems like, for example, using very long-term attention, right? So actually being able to attend on some thousand points behind, right? So it's a problem, right? But there's active research on this, and there are multiple different both companies and universities which are working on this. What's worth mentioning is that the number of papers and the results are actually increasing, right? So still, as I showed you, 2023, there was no big progress. There were lots of papers, but still the statement looks like it's still not transformers in 2023. But actually, what we see is that at 2023, at the end of 2020, 2024, actually we start to see now pre-trained models with time series forecasting. I'm going to show you on the next slides. But yeah, for example, at 2023, there's one interesting paper. One interesting paper which is are transformers effective for time series forecasts, right? And actually, they're quite not just this one. There are also other papers which are showing that yeah, we have this transformer architecture, which the previous paper claimed that it's the best. Now we are using some linear model, and it's better from the previous architecture, right? So it's a little bit frustrating, but again, the expectation is that it's going to be better transformer because everything, all the current problems are solved with the transformers. And yeah, just saying this, I'm just going to start something from the last 2 days with GPT 4.0, just to see why we're expecting that transformers will be able to do something. For example,
Okay, ChatGPT, I'm sharing with you the plot now. I'm wondering if you can give me a really brief one-sentence overview of what you see.
The plot displays smoothed average, minimum, and maximum temperatures throughout 2018, with a notable annotation marking a big rainfall event in late September.
Fantastic.
okay, yeah, it's not from forecasting, right? But it's being able to see here. So there is multimodality.
The maximum temperature, 77.
So I'm not being able to go on the next slide.
This is in Celsius.
Okay.
Temperature and max.
Okay. Yeah, and starting around this time, so for the last 6 months, we start to see actually quite a lot of research which is trying somehow to create the same methodology, right? We have these large language models, which the language more or less is some time series of letters and words, right? So we have large language models which are being able to learn and to generate something for the future, right? So it's just logical that we could use it for time series, right? For time series forecast. So for the last 6 months, and actually before, I didn't saw, to be honest, any pre-trained models, right? But for the last 6 months, there are quite a lot of them. So starting from Wagwana, which is a pre-trained model, which you could use as a universal forecasting model to show. Here is examples of my of my sales for the last months or year, right? What's the forecast, right? So starting with Wagwana, after that going to moment, and up at the 2024, we see actually quite the big density, right? So February, March, actually this Times FM, which is going from Google Research, was just a few days ago published as an open model to be used from everyone, but yeah, the paper was from before. And yeah, we have actually quite big density of these models right now happening, and they're performing actually quite well. Of course, yeah, based on what their developers are saying. To be honest, we didn't benchmark them too much, right? So this is also going to happen. Right, but the main idea here is that you need to have universal forecast, right? So you have data which is coming from lots of different places, right? So battery status, sales, traffic, weather, and stuff like this. And all this is more or less the same. Sometimes there's signals, probably multiple of them, which are on which you could train, and for the future to be able to recognize the different patterns in order to forecast the future, right? So getting different signals, you could get again multiple of them. You need to understand somehow the distributions, and actually what here I'm showing a little bit about Salesforce Moire model. But what they're doing is that they're forecasting for the future, as they're actually giving the option to use to forecast multiple time series at the same time, and also to use time series which are additional information, like for example events. So they're just they're of course explaining the paper which they have given, but they're splitting the data on different chunks, which they're aligning with time ID in order to know that this chunk here, when you're training, it's happening at the same time with this chunk, which is different time series here. And also we have this related signal, which could be something else, right? Weather, for example, right? We know the weather, but we know also we have the weather forecast for the future, right? So you could also get it for the future as well. Yeah. So this one is going to be available also on the test set when you're testing. These two are going to be hidden, right? So you could actually train and after that to forecast for the future as well then. Yeah, as what they're showing actually from Salesforce Moray is that they have different type of models and they're the best, right? So when they're compared with others, yeah, for example, here is ARIMA, but we also have CatBoost, which is a gradient boost model, right? We have also WaveNet, which is a model from before from Google for autoregressive model. And MBITS is actually one of the models which was compared with gradient boosted models for example, also for M5 competition. So they're the best, right, with scores there.
Are they all open source or not?
Yeah, they're a bit. Also, you have notebooks which are showing how to use it. For Moray specifically, it's a notebook which you need to make environment and stuff. For example, they don't have co-op environment. We have very good immediately start. For some of the others which I'm going to present, there is one co-op notebook which you could immediately start. Yeah, TimeSapiens, it's coming from Google research. Again, just the last days, it was uploaded with the base and the models, so the biggest one which you are able to use. Actually, they're claiming that they're using hundreds of billions of forecasting points, right, to train the model to make it. But there are few problems with this model compared with others. So first, data for example, Moray, and after that we are going to synchrons. Also probabilistic forecasting. So, for example, for stocks, if you have a value, you want to know actually how probable it is. So this is a little bit that's what Google is giving, and yeah, they have some limitations of the number of data points which you could present to them. Still, based on their benchmark, they're the best. The problem here is that they're using very similar method with the previous one. The things are different here. So because they also have compared similar models like WaveNet, CatBoost, ARIMA and stuff, they're a little bit shuffled here compared with the previous. So actually, rerunning of the experiments with the same metric and stuff is going to be interesting. But I suppose they have done this in order to be the best, right? Something interesting actually what they have done from Google is a little bit advertising for OpenAI. They can actually benchmark compared with GPT 3.5, right? So yeah, I'm going to leave the technique behind this unmentioned, but this LLM time ZS is somehow using GPT 3.5 and actually making forecasts. So making somehow these are the values, what is the next? So some interesting prompting. And so 3.5, something else what they report is that actually their benchmark against GPT 3.5 they're better, not so big to be honest, but they're also over, of course. They can compare also with GPT-4. With GPT-4 the results was worse. Right, so GPT-4 was not working as well as 3.5. for forecasting of the time series. Okay, and going to the last but not least, Chromes. It's coming from Amazon Research. Again, it's coming at the last month. It's from February 2024. It's making it's using T5 architecture, which is purely LLM architecture, which is before the GPT-2 coming, and it's again trying to match the different to match and to transform the task that the time is used and the time is used as it's needed for the time series, and actually the things are trained on it. As this time they're not showing that they're not the best. Yeah, they're probably trying to be fair. And TFT on some of the experiments which they're doing, again, these are different benchmarks. This aggregate relative maze is probably maze is a mean absolute scale error. It's similar to the previous one which they were showing. Here actually we have more area because it's concatenated. So more area is here. Chrome's T5 is here, so it's better compared with more. Yeah, and Wacom and Dallas. Right. So they're showing that they're better and they're not the best. That's interesting. So PST, which is another transformer model, which is trained specifically for these tasks, is performing better. This is actually probably quite important to mention here. So all of this what they're comparing is what's happening with zero-shot learning. So you're getting the model does not know about this data set. That's very important. Doesn't know about the data set. You're just giving to him a context window, right? So this, which could be quite large, right? It could be, let's say, the whole history of the location. This is how the location was formed. What do you think about the future? And it's without training, so zero shot is giving the results. So Apache TST, which is transformer-based architecture, again based on training of specific models, is performing better. And FIX, which is again neural net architecture, but not transformer, is also working better than Chrome's large based on their results. And some summary and conclusions. So, from my point of view, for sure, the time series forecasting need to be solved with machine learning, right? And currently, from my point of view, still, if you are starting, probably you need to start with gradient boosted methods. Probably you could test some of the latest pre-trained models to see are they working for you, because again, they're models every month, more or less. So in 3 months, for example, they could be just a huge improvement to the models and stuff like this. The transformers are heavily currently researched for time series forecasting, so I believe that they're going to be the future, right? It's still something what needs to be proven more, but we are close to this edge. And there are multiple prepared models, and my expectation is to get one more next month. Currently, there are some of the things which, for example, Google are offering is to use pre-trained models and also to use additional models and probably ensemble models as well to add more specific things like specific events and stuff, which actually, the models cannot learn about them from before, because just there was not such kind of events in the data sets on which there was presented, even though data sets are actually quite large they're using right now. It was different. And that was it. I have here just I have here also just to show you co-op notebook, which is from Chrome's. It's a purely co-op notebook, so you could just, if you look for Chronos, right, you could see it. It's, I haven't added anything here. I just played a little bit to see how fast it is and stuff like this. And okay. Yeah, and yeah, what I could say about it is that it's relatively slow, to be honest. This is one of the things which are specific for the pre-trained models, that they are actually not paying zero-shot learning. So actually, they're looking at all the signals and using it in order to forecast the next step. Yeah, you're not going to see the notes, but everyone can see it by itself. What we have is that we have pre-trained model, which is very easy to take, use on data sets, actually to change data set and to see how it's actually performing. Everyone can do it by himself. So, and that was it mainly for me. Thank you. Question. Do you have any other positions at the board? So we have data science and data engineering positions. Thank you for asking.
Okay, which is the next window of the M7? Can you forecast that?
First we need to see what's going to be the competition itself, right? Because with the M6 being on the stock market, actually the bar is quite high, so it's interesting to what's going to be the next one.
I'm more interested in the production side. So how you handle the models, operating with the models, what's the time of, because you mentioned the 5 minutes period, so just curious of this, how many models you maintain, what probably is the granularity and where and how it's happening.
What models? Thousands.
Thousands.
Yeah. The main thing here is that you need to have a very good infrastructure based on what to be optimal for having new data, doing inference, storing the models, being able to deploy new ones and new changes, to get out to train on the models as well. So it's quite broad and big topic. Probably we could make another lecture on it, but it's something quite important for production, right? So, but what you need to have is to build an infrastructure where you could do experiments, and when you're doing experiments, to use production data and to ensure that you're using the same data on which after that is going to work this model. Because if you're copying it and transforming it, at the end, these models could mislead you. So you're using the same data. It's actually, what I'm going to explain here is more or less the MLOps infrastructure. So you need to follow the highest function to definition of the MLOps infrastructure in Google, right? In order to have a stable environment where actually you could follow the models, their performance, to retrain frequently, having auto-train, also to have development environment where you could experiment with new things and to have a proper process of deploying them into production, right? So this transferring, copying models to production and stuff like this is not great. You need to have, we are using Azure infrastructure, right? So we are using Synapse pipelines. From there, they're using machine learning pipelines. We have Azure DevOps pipelines which we are promoting between different environments and stuff. And yeah, that's mainly, I mean, the topic is quite extended, so we could speak a lot more on it. That's okay. It's 8:13. So I believe let's say that that was for today. Next time we have just in less than 2 weeks another meetup, which is additional one, which is going to be with UVCom from Qualcomm, which is going to be on more data engineering thematic, right? So we're going to see their Apache arrow using Berkeley and some more specific there for the people which it's going to be open applications. You're going to see an event there. That's for it for now. There is still some pizza also here. You saw that back there. Drink also here. And yes, please. So thank you. Thank you.